Alright, in this next section here, we're going to introduce something that, again, you should have learned last year in Algebra 1. It's solving systems of equations. It is an important tool that we use throughout the book, and so just wanted to do this early on in this school year. So, there's three different ways that you should have learned how to solve systems of equations. The first one is to graphically solve it. So let's graph this system of equations. We've got two lines here, and we can graph both of these. So for the first one here, let's say y is equal to negative x plus 5. Go ahead and solve this thing for y also. Put this into slope-intercept form. Y equals, if I solve for y, 3/2 x minus 10. So if I graph this, it's going to be at y-intercept of 5. Negative 1 is the slope, and there's the equation, there's the graph of that first line. The second line, which is this one, goes through the point negative 10 down here, up 3 over 2, up 3 over 2, up 3 over 2. It looks like it should intersect right here. Okay, and messy there. Okay, and what that tells you, if you can spot the intersection point, is at 6, negative 1. It tells you that this is the solution to that system of equations. In other words, that is the one point that when you plug it into both of these equations up here, it will satisfy both equations. Okay, so when you are solving a system of equations, you are basically finding the intersection between two lines. Now there's two algebraic methods to solve these systems. The first one is substitution, and so when I have, well actually I can use these two right here, because they're both solved for y, and so I can basically take this and substitute it for the y in the other equation. So I'm going to get negative x plus 5 equals 3/2 x minus 10. I can go ahead and solve this thing. Something that you may choose to do if you want to make life easier is just multiply the entire equation, both sides of the equation, by 2 to get rid of that fraction. So you get negative 2x plus 10 equals 3x minus 20. You don't have to do that, but I do that sometimes just to make life easier. 30 is equal to 5x. X is then equal to 6. Plug 6 back into either of the equations. Probably the first one makes more sense. And you get y is equal to negative 1. Which is good, because that ends up being the solution that we found graphically up above. Linear combination, otherwise known as elimination, okay, is basically the one where you do like something like this, x plus y. I'm just going to rewrite the system. It's where you, like, for example, take the top equation. You can actually multiply both equations by something, but in this case, just multiply the top equation by positive 2. And so I can rewrite this now as the top equation is 2x plus 2y equals 10. Bottom one I'm just going to rewrite as 3x minus 2y equals 20. And what I'm allowed to do, because all the stuff on the left-hand side here is equal to the stuff on the right side, the left side equal to the stuff on the right side. So if I add the left side stuff together, it's still going to be equal to the right side stuff. It's going to look a little different, but it's still going to be equal. The nice thing here is when I do that, hopefully you can see that this is going to cancel out. that my y's are going to go away. And so that leaves me with 5x equaling 30, or x is equal to 6. And then you can just go ahead and plug 6 back in for x there, solve for y. Y ends up being -1, just like we had solved in the previous problem. Okay, so that's solving systems using 3 different methods. We can jump to the next page here if you want. Let's jump to the next page and just talk about a couple of things. So the first thing here is that, let's say I'm doing number 2 here, and I'm solving this equation, or solving this system, and so I want to maybe solve this second equation here for y. So I divide everything by 2, the y equals 1/2 x minus 2. And so now I have a system that looks like this, and I can go ahead and substitute this in for this y here. So I get 1/2 x minus 2 equals 1/2 x plus 3. If I subtract 1/2 x from both sides, I get -2 equals +3, which, oops, does not look like a real good thing to have, because we know that that's not true at all. So what do we have here? Well, we have no solution. Why do we have no solution? Well, if you think about it, if you take a look at the original problem, if I take a look at this and I take a look at this, what kind of lines are those? Those are parallel lines. And because they have the same slope but different intercepts. And so when we look at something that has parallel lines like that, they are never going to intersect. So that means that you have no solution for solving the system or finding the intersection between the two lines. The other thing I want to show you is down here. Seems like doing substitution would be a good idea for this, because it's already solved for y. Substitute this in for y. I get 2 times 2x plus 1 minus 4x equals 2. And distribute the 2, you get 4x plus 2 minus 4x equals 2. The 4x's drop out. 2 is equal to 2. Now that's different than the problem up above, because we know that 2 equals 2 is a true statement. And so in this case, what you actually have is these 2 equations at the start, these 2 up here, are actually the same exact equation. They represent the same line. So when I solve a system for this, it's going to be all points on y equals 2x plus 1 will be the solution to that system. I think I'm going to stop here and let you try. Okay? All right, take care.